Hello everyone. Today we have Pre-Calc Lesson 31, Symmetry, Reflections, and Translations. This all have to do with functions and graphs of functions. We will actually be doing this more in depth when we get to trig functions, when we get up to, I think it's lesson 80 something. But right now we're just going to do it with our basic functions. So let's talk about just basic symmetry. Basic symmetry, we have reflections, which are mirror images over the point of symmetry. Okay, so the easiest one to look at is, let's look at y equals x squared. Okay, if I just draw a sketch of that, that's my x-axis, my y. I know that it's reflected about this line right here, the y-axis, meaning if I was to fold my paper in half along the y-axis, my graph would exactly fold on top of itself, okay? That is a reflection. Now, there is different symmetry. We can have symmetries about axes, our x-axis and our y-axis. Okay, so symmetric about the y-axis. Okay, what it means is if we replace x with negative x, the results are equal. We're going to later call this an even function. So what does that mean? If I say f of x equals x squared, if I plugged in f of negative x, so I would have negative x squared. Remember, whatever I plug in here for my argument goes into my x. We all know that negative x squared is the same thing as x squared. So it means I'm symmetric about my y-axis, just like I drew right here. Okay, it still gives me the same positive answer. Now, symmetric about our x-axis, that is when we can replace y with negative y, and the results are equal. Okay, so say we said x equals y squared, right? If we were to replace that with negative y squared, that's the same thing as y squared. And the graph looks like this. It's symmetric about the x-axis, meaning if I was to draw a dotted line on the x-axis, fold my paper there, my graph would exactly fold on top of itself. Okay. Now, there's one more symmetry. Symmetric about the origin is symmetric about both axes. So what happens is if we replace x with negative x, the result is the negative equation. So I'm gonna write it how your book writes it so that there's least confusion. We're gonna also replace y with negative y. If you do both of these, it results in the same equation. Okay, so this is what we call, or this would be an example of a circle. A circle, we have x squared plus y squared equals r squared, r being some constant. And if we were to replace x and y with negatives, it would still give us the same graph, right? These are the same, which would just be a circle like this, right? Meaning if I folded a paper along the x-axis, it would fold on top of itself, or if I folded my paper along the y-axis, it would fold on top of itself. Okay? these are the main graphs we're going to look at right now. And we'll do examples with those in just a minute. Okay, but that's the main symmetry we're talking about. Now let's talk about reflections. Okay, reflections are when we replace x with negative x to reflect a function over the y-axis. Okay, so if I had the graph y equals, let's say, x squared plus 8x plus 16. You don't need to know how to graph this yet. I'm just going to show you. It looks like this. Okay, it has symmetry along this point. Okay, now if I was to replace x with negative x, so negative x squared plus 8 times negative x plus 16, it would flip it exactly over the y-axis. So here I have 1, 2, 3, 4. I have negative 4 at my vertex here. Here I have positive 4 at my vertex. Okay, so it reflects it across the y-axis. Now, if we replace y with negative y, then we reflect across the x-axis. So if y is f of x, then y becomes negative f of x. So in that same example, actually I'll just use, if y is x squared, okay, if I was to graph y is negative x squared, notice the negative is outside of the x, not inside of the x. It flips my graph down. Okay, here's the key in all of this. Reflecting across the y-axis, the negative is inside of the parentheses with the x. The x is being affected. That's why our x value goes from here to over here. Our x value changes. It's almost like a horizontal shift. It's not a horizontal shift, but it's like it because the x is affected. Now if you look down here, the y is affected, meaning the negative is outside of the x term. So that's why we flip up and down. We flip vertically. We flip over the x-axis. Okay. Let's talk about translations now. Okay, a horizontal translation is the x term, right? So we are replacing x with x plus or minus some h. Okay, if we have x plus h, this shifts us to the left h units. And if we have x minus h, this shifts us to the right h units. So if I started with this graph, y equals x squared, okay, it's at 0, 0. This is 1, 2, okay. Now if I was to do y equals x plus 2 squared, it would move me to the left 2. So now my graph would be at negative 2. Likewise, if I was to have y is x minus 2 squared, I would move to the right 2. Again, the horizontal stuff, the x stuff, is inside the parentheses with the x. Okay. Vertical translations, they are dealing with y. So if we replace y with y plus or minus k, if we have y plus k, it shifts up k units. And if we have y minus k, it shifts down k units. So let's look at the same case. Y is x squared. If I write y is x squared plus 2, completely outside of the x term, then I'm going to shift up 2. And if I have y is x squared minus 2, I'm going to shift down 2. Okay? All right, so let's do some examples. We want to sketch y equals the square root of x. Okay, now I want you to write it how I do. Okay, now we know that the square root of x, we are not going to plug in negative values for x. We can't go negative. So we'll start at 0. Let's do 1, 4, 9. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. There's my graph. Now I'm going to label my points. Okay, you can label just as many as I do. You don't have to label much more. Okay, that's the graph of y equals the square root of x. Now, we could say, write the equation of the graph with the same shape, but reflected over the y-axis. Okay, reflected over the y-axis. So, and we want to sketch. Okay, now we remember that to reflect over the y-axis, okay, I am affecting the x. So before I just had the square root of x, now I'm going to have the square root of negative x. I replace x with negative x. Okay, now we know we can't take the square root of a negative number, which means that all of my x values besides 0 must be negative. So now I have to do negative 1, negative 4, negative 9, which if I plug in negative 1 for x, negative 1 times negative 1 is 1, okay, which makes me able to plug in negative values. And reflected across the y-axis means my graph looks like this. I still have to label points. This is negative 9, negative 1, negative 4. 1 is at 1, 2, 3, 4. 4 is at 2, almost. 9 is at 3. Okay, that's all that it's asking for. You need to know how to have the same graph, but reflected. Let's do another example. Sorry, guys. All right, we went to sketch. Okay, now we know that x cannot equal 0. So on my graph, I have an asymptote here at x equals 0. and I need to get some behavior to the left and some to the right. So I'm going to do -3, -2, -1, 1, 2, 3. We know that 0 is undefined. So if I plug in -3, I get -1/3, -2, -1/2, -1, -1, 1, 1, 1/2, 1/3. So -1, then I get -2 is -1/2, -1/3, and 0. That's half of it, and then I have 1, 2, 3. 1 is 1, 2, 2, 2, 0. Okay. You should be comfortable with graphing things with asymptotes by now. Okay, this should be second nature. Now, if we want to write the equation of the graph, has the same shape but translated 3 units left and 4 units down. Okay, so I want to write the equation and sketch the graph. So my first equation is this. 3 units to the left means I'm going to just be dealing with x. So 3 units to the left, I will have on bottom x plus 3. Okay? Now, 4 units down, I deal on the outside with y, so I have -4 out here. That's all that it is. That's my new equation. Okay? Now, I have a new asymptote. Okay? I know that x cannot equal 3. So, -3, excuse me. So if I plug in -3, it's undefined. So now in my graph, -3 is my asymptote. Okay. Now my values here, I was moved to the left by 3 and down 4. So I take each of my points that I have, -1, 1. -1, I move it to the left 3, which gives me -4. And then -1, I move it down 4, which gives me -5. So at -4, I'm at -5. Boop. And you can still plug in the same points if you want. Okay? Or you can know that this is kind of how the graph is going to go. So -4, what did I say, -5. Okay, if we plugged in -5, you can plug in -5 to here, which -5 plus 3 gives me -2, so we have -1/2 minus 4, which gives you -4.5 or -9/2. You could also have gotten that from here. So -5, -4.5 is here, and our graph is going to look like this. Same graph, just shifted down. Now, my 1, 1, I move to the left 3, so I'll have -2, and I move down 4, I'll have -3, so -2, -3. Okay, and then I'll have at -1, right, that would be, if I plugged in -1 here, I would have 1/2 minus 4, which is -3/2, which is -7/2. So -1, I have -3/2. And there you go. Okay, my center line here at x equals 0 has also moved down 4. So it's now about at x equals 4. Okay, those are the big key things you should be looking for. Okay, let's do one more. Back to this graph, y equals the square root of x. I'm just going to sketch it now. Okay, we want to write the equation of y equals square root of x reflected over the x-axis and translated left 3. So what would that look like? Translated over the x-axis would have me here, and moved to the left 3, would put me like this. Okay, this is just a sketch. If it asks you to graph, you have to actually put more points on here. Now we know to flip over the x-axis, I put the negative out front on the y, and then left 3 I will have x plus 3. And that would be my new equation. Okay, you should be very comfortable with graphing by now. If you're not, you need to come ask for help. All right, that's all for today.